Hello, everyone. My name is Jonas Mendes, and I'll talk about creative coding today. And, well, I'm a developer for around like 8 years, almost 8 years now, like a web developer. If you want to know more about me or connect, there is this link. I won't spend much time talking about me. I'll go directly to the point. And I'll go through these subjects. So creative coding, generative art, simple use case, like how you can actually use this stuff on your work or how it was used in some place, somewhere. I'll show an experiment that I've been playing around with. I hope you guys like it. And I will go over some of the technologies and methodologies that I used to create the experiment and to put it together. Weird that this thing is not showing the slides, but I guess that's fine. So, who of you ever heard of creative coding before or generative art? Oh, that's nice. So I guess I don't need to explain to everyone, but anyways, a creative coding basically is about coding something that will generate something expressive rather than functional or to solve some data problem or whatever. And I remember when I was in Brazil working for a digital agency, a friend of mine introduced me to creative coding. And at first I thought that this kind of stuff only happens if you work with games. And I was working a lot only with data all the time and only with like functional stuff. And to be honest, back then, to be completely open, I wasn't very good at expressing myself and expressing things that I feel inside of me. I imagine that some of you can relate to that. And to actually get to this world of using a skill that I already have, which is coding, and actually creating something cool and expressive and be able to actually express emotions that I don't even have words for. That's, I guess, what art is about, right? You don't have words for it. It's something way more complex than our language can even conceive to another human being, and then you can need to create something more, and the other person will relate to that in the way that they relate. And yeah, that was very cool. And then I started to play around with it slowly. I didn't go directly into it, but I played around with it slowly. But okay, besides expressing yourself and getting your emotions out of your chest and expressing that to someone else or even to yourself, there are also some use cases that I would like to show. So this is a use case from a telecom from Brazil. The one on the left is the old logo. The right is the new one. And actually, this new logo is generative. It reacts to sound and to any data, to be honest. And it's quite cool how they did the rebranding of it. And it shows kind of what you can do with such technology. And another use case that I would like to show that is one of my favorites, it's actually to make it easier to convey information to the user in a way that he can conceive instantly. So this website is showing more or less the change of the planet before human beings and today. So you can click on it and it will actually animate and show the change that happened. And yeah, okay, you could show that with data, right? Like you could show numbers and write a text about a research that was done. But to really conceive what those numbers mean in real life, in the real world, something visual like this, representing actually like a visual representation of what's happening, it's way more conceivable for normal users especially. So these are the two use cases that I wanted to show. And now I will show the experiment that I have been playing around with. So I will talk about the technologies that I used to create it. And this, for now, is a sphere, as you can see. And if I change this, I'll get some cool effect. And this is a 3D shape. Is a 3D mesh made with FikaJS. And not only you can do that, but you can play around with it and create something visual. And not only be static, but actually react to something. And in this case, I put some music. So, yeah, right now it's reacting to the sound that is playing, but it's quite low, I think. Maybe to go louder person. So as you can see, all the waves are being done based on the current moment of the track that's playing. And that, at least for my case, it was something more expressive than trying to conceive any information about nature, like the other example. But still, I still value a lot self-expression, and I think it's a great way to do it, especially if you have skills with coding. And you don't need to use music necessarily. You can also use input from the microphone or even from the webcam. Any kind of data, you can actually react to it. But for some reason, it's not really working with the microphone thing. That is weird. Well, but you get the idea of the previous demo. So this is the experiment that I did, and I'll go over the technologies and what I did to make it work the way it does. So first of all, FikaJS. It's a library that wraps up WebGL. So instead of having to use the native APIs of WebGL, you can have a wrapper that is way more user-friendly. Many wrappers, actually. And yeah, at FikaJS, basically you can create geometrical shapes with it. And much more, actually, but that's what I'm doing on this experiment. And you need a few entities to actually have something on the screen. You need a scene, which is basically the universe where your 3D world and objects will live in. A camera to conceive that space. A material, a geometry, and then meets these two into a mesh, which is actually the final form. But I will focus, we don't have time to focus on all of them. So I'll focus just on the material real quick. So this is an instantiation of a shader material from FikaJS. And you can see uniforms. Those are, I will mention later as well, but those are actually values that I'm passing into the shaders. And I'll also explain what shaders are soon. And here you can see the shaders being passed. So we have two shaders to create this shape, this mesh. We have the vertex shader and the fragment or pixel shader. Some people call fragment shader and some pixel shader. And yeah, so there comes to GLSL. Whoever heard about shaders here? Nice. Yeah, actually I just started to actually play around with it recently. So GLSL stands for OpenGL Shading Language. It's actually a specification that majority of hardwares, as far as I know, is majority. Only some of them follow different specifications and are a bit different. So it's a specification that hardwares follow, like the graphic card. And this language is actually executed by the graphic card directly. So it's not the CPU executing it, so it's way faster. It's directly the rendering thing. And actually, you can code them on the web like this. You just define a script tag and define the type to be a shader, either a vertex or a fragment shader. And a fragment shader. So this is an example, like a very simple example of a fragment shader. It's a function that runs for each pixel on the surface of an object or on your area where you are working with. And on this case, I'm just assigning the fragment color to a green color. So that's basically RGBA. And as you can see, the square and on the right is entirely green. But you can actually do way more with that. Like you can even draw shapes, fractals, and way more stuff. Like people really master this and manage to create very impressive things only with fragment shaders alone, not even using a WebGL, a 3D library or anything. And this is the link for that page. And vertex shader. So vertex shader is about, like the fragment shader we saw that is about each pixel and the color and the alpha channel of that pixel. So vertex is about the vertices of a shape, of a geometry shape or any shape. And that's how it looks like, a very simple one. So it's a function that also runs for each vertex of a shape. And you can assign a new position to it. So instead of changing color or anything, you change the position. So vertex shader is mostly to change the positions of the vertices and modify the form that the shape is going through. And in this case, it's very simple. It's just increasing the x and y of those vertices. So this is an example of a shape and its vertices being stretched and being modified by the vertex shader. And this was supposed to be a GIF, but I have it running here. There you go. Like it's a shape with very small amount of vertices, and there's a shader there just modifying it in a gentle way, so you get this effect of the vertices moving. And yeah, I can actually show here that you guys probably notice on this shape, there are way more vertices. That's why you get such a way more detailed effect on it. And also it's more cost to process and to go over all the vertices all the time. And yeah, but it's more detailed. So yeah, and as I said, if we would do that with the CPU, you would have basically that visual representation going on. And if you do with shaders, you would have the parallelism of the GPU and everything would go quite fast compared to the CPU especially. So if you're doing something very detailed and complex, don't use JavaScript or a language that is using the CPU. Actually try to use shaders. That's what they are for. And well, you might wonder how do you get the actually wavy effect on the shape. So I'm using Perlin noise for that. Who here heard of Perlin noise before? Okay. So this is an algorithm. It's quite generative, and it was created by the guy that was working on an institute, and he was asked to create something for the movie Tron. And actually, what he created is this algorithm to do the textures of everything that was on the Tron movie. So those textures, they were using a Perlin noise algorithm to be created generatively. And it's used still to this day for many, many things. And here you have a representation of the random. So the black line, which is going quite crazy, is the random function. Imagine that you're just calling random from 0 to 1. And that is quite unstable and, as it says, random. And the red line that you can kind of see in the middle, following also the randomness, is the same thing, but using Perlin noise. And you can see that is way more like a natural, organic flow than the random one. The random one is not that pleasant to the eye. I guess depends on the person, but yes. And that's basically what's happening on that experiment. I'm using Perlin noise to modify the position of the vertex. And then I get that around the effect. That's not the only thing that you need. It's not only Perlin noise, you also need to calculate with the normals of the shape. So it knows where to go. And here's an example of Perlin noise. So on the far left is just a normal fragment shader modifying color. And you can see this smoky figure. And then in the middle, it's that same data. It's used to create elevation and a texture. And that texture is obviously also reflecting light. So there is more to it rather than just Perlin noise, but you get the point. And then the texture is actually being used on a shape, on a spheric shape. And then you get sort of planet, Pluto maybe, I don't know. And yeah, you can also find this algorithm on the P5 library. So this one, as far as I know, I'm not sure if they do any optimizations on it. Maybe they do, but it's a JavaScript function. I don't know if they run shader on the background somehow. But yeah, you get exactly the same effect, like a wavy landscape, liquidish. And this is actually a link that is on the PDF, and you can copy. And yeah, further these things that I used, I also used some web APIs. So in this case, it was only the audio API. And yeah, basically, I was using the audio context and the audio analyzer, like I create the analyzer from the context. This API is a bit weird, in my opinion. I think there's a wrapper for it if you don't want to use the pure one. But in this case, it's the pure API. You can find it on browsers and stuff. And on this case, I'm selecting an element that is a track, audio track. It has an ID track. That's why getting the query selector there with track. And you create a media element source from it. And this source is also the same source as you use for the microphone, but the API is a bit different. It's just one line change, basically. And you get the user media. You use the get user media API, and then you can get webcam, video, audio, stream of data, and then you can use that to apply to your experiment, whatever you're doing. And then here you connect the source with the analyzer, and you define a data array, and you plug that analyzer with the data array with that frequencies of the moment of the track. So you get an array of numbers which represents the frequency of that specific moment that the track is playing, the music track is playing. And with that, if you remember, on the 3JS shader material, I can pass it in as a variable. So I call it displace intensity, and it's a float on this case. I'm still seeing if I can pass the entire array to it, but in this case, I'm only summing up all the array and passing a float. And with that value on the shader, I'm able to use the music moment to define how much intensity I want on the vertices change and etc. And also on the color, you could use anywhere on the shader, actually. And then you get this that I showed you. And yeah, there are some more links that I added to the talk. So this guy, I really recommend following him. He was actually the guy that developed and wrote an article on generating this spheric wavy effect. And he publishes a lot of open source stuff. And like, you don't need to be an expert to create such experiments. You can actually just see what people are doing around and plug stuff together, just to do like with normal coding. Like, you usually don't code everything from zero. You don't do a framework all of it, like by yourself. So you can really copy paste stuff and use existing things that people did, and with that connect to music, connect to something else, and change the color, change the way it reacts, tweak with values around, and find out how it works. Like, you don't need to understand deeply those algorithms and those concepts. They are all ready for you. So you don't need to develop the Perlin noise algorithm yourself. They are actually ready on GitHub. You can just copy paste it and use it on the shader. And yeah, there's a further usage for it as well that I love. So in this case, it's basically an art installation. This guy, he actually also did such visualization on an orchestra. So there was somehow something receiving the light of a projector or something, and then on top of the orchestra there was such 3D form reacting to the music and all of that. It's quite amazing. And he also does it on buildings. He did it on the Disney Hall, concert hall. So this is another use case that I love. And if you don't even want to code, you can play around with generative art and creative coding quite easily with this too. So this is quite fun to play around with, especially if you take the time to tweak all the variables and etc. And yeah, like 3JS is not the only framework. I showed P5JS. And a great way to learn shaders is actually this book. So the book of shaders, this moon itself is a shader, and the guy that wrote it goes through everything that I'm speaking here, even in more depth. So if you want to really get into it and get good at it, like, this book is the place to start. And there are other companies actually using creative coding and this sort of coding to, like, on clients and stuff. So I also added some links to these companies here. So yeah, that was basically it. Namaste.